Assalamualaikum and hello everyone. My name is Aina Shikin binti Kapor. We'll present to you my final year project research studies with the title of The Synergetic Effect of Fly Ash Concrete Mix for Sustainable Construction. The table of content consists of introduction, problem statement, objective, material use, methodology, and conclusion. What is concrete? Concrete is a composite building material largely made of gravel, cement, and water. Concrete is commonly regarded as the first extensively utilized construction material in the world. It has been widely utilized in the development of buildings, bridges, highways, dams, and a variety of other civil infrastructures over the years. Any development effort that aims to improve livability will have both good and bad consequences. The development project should be planned in such a way that it has the greatest beneficial influence on the environment and the least negative impact. Next, moving on to supplementary cementitious. Nowadays, most concrete mixes include supplementary cementitious elements that contribute to the cementitious component of concrete. These are often byproducts of other processed or natural materials. They might be further processed for use in concrete or not. Some of these minerals are known as pozzolans, which have no cementitious capabilities on their own but react with Portland cement to generate cementitious compound. According to Bakar, Putrajaya, and Abdul Aziz, supplementary cementitious ingredients have shown to be effective in meeting the majority of the requirements for long-lasting concrete, and blended cement are now widely utilized across the world. Fly ash. Fly ash is a fine gray powder consisting mostly of spherical, glassy particles that are produced as a byproduct in coal-fired power stations. Fly ash has pozzolanic properties, meaning that it reacts with lime to form cementitious compound. It is commonly known as a supplementary cementitious material. Fly ash significantly improves concrete performance and also provide many benefits in cement and non-cement application. Also, when treated with sodium hydroxide, fly ash appears to function well as a catalyst for converting polyethylene into a substance similar to crude oil in a high temperature process called pyrolysis. Coconut husk fly ash. Coconut husk is an agricultural waste that is abundant in tropical areas across the world. Coconut is known as the tree of life by certain tropical cultures because of the fresh and milk of the nut provide food and drink. The tree's trunk provides attractive and long-lasting timber for their homes. Coconut husks could also be used to make floor mats and garments. In addition, coconut fly ash has been shown to be a partial replacement in concrete in previous investigation. Moving on to the problem statement of this study. The cement manufacturing process is one of the world's third greatest CO2 emitters. According to Malthora, during this process, more than half of all CO2 emissions are discharged into the atmosphere for every ton of cement produced. These greenhouse gases, such as CO2 and SO2, contribute to ozone layer depletion, which causes global warming. On top of that, this significant rise in carbon dioxide emission from cement manufacturing. Bamboy and Jekainfa expressed their dissatisfaction that 90% of coconut trash, such as its empty fruit bunches, husks, trunks, and shells, was dumped as garbage and either burned in the open air or deposited in waste ponds. According to them, the industrial waste generated by coconut processing contribute considerably to CO2 and methane emission. Based on economic and environmental consideration, global efforts should be directed addressing coconut management challenges such as utilization, storage, and disposal. Coconut husk ash also. The objective of this study include to optimize the ratio of fly ash as a substitution material in concrete, to investigate the physical properties of fly ash concrete mix, and lastly to study the synergetic effect of fly ash as a partial cement replacement material in construction. This study required ordinary Portland cement, 40G grade, coconut husk fly ash, water, coarse aggregate, fine aggregate, and etc. Mixed proportion. This table shows the mixed proportion of percentage of fly ash that will be used in the studies. Fourth set of mixed proportion is prepared. First is the control mix without fly ash, while other mixes contain coconut husk fly ash. Coconut husk fly ash is used as partial replacement of cement as 0%, 5%, 10%, and 15%. Preparation of coconut husk fly ash. The following procedures outlined below will be used in the production of the coconut husk ash. First, collect the coconut husk from source. Second, sun-dry the husk in the open field for 7 days. Third, burn the dried husk at an average temperature of 100 degrees Celsius using cooking gas as combustion medium. Fourth is to allow the burned products to cool off, then collect and sieve using sieve size 600 μm. And lastly, use the materials passing 600 μm sieve for the practical work. Mixing of raw materials. Weigh the required quantity of cement, fly ash, fine coarse aggregates, and thoroughly mix in dry state in a mixing tub with the help of trowel. Mix the mixture in dry state until it attains a uniform color. When the mixture attains uniform color, weigh quantity of water is added in the mixture of cement, fly ash, fine and coarse aggregate. After addition of the required quantities of water, mix the mixture thoroughly with the help of trowel in the mixing tub. After mixing the mix initially with trowel, mix the mixture again thoroughly by kneading until the mass attain a uniform consistency. Use the standard normal consistency test to calculate the quantity of water to be added and determine the water content for the normal consistency. Preparation of brick molds. Place the mix binder in the brick mold and compact it properly using trowel. Hand finish the excess paste. Fill the mold in 3 layers and compact each layer properly. Therefore, to conclude, according to previous studies, the utilization of supplementary cementitious materials in either cement or concrete can compensate for environmental, technical, and economic issues caused by cement production. Most of these supplementary cementitious materials are byproducts, and their inclusive serves as an invaluable means to protect environmental resource and the production of durable concrete. The use of supplementary cementitious material reduces porosity of concrete, as can be seen from the air entrainment test, thereby leading to the production of durable concrete.